Welcome to JAMB Physics class. So, in today's class here, we're going to learn about elastic property of solid, which is one key aspect of JAMB Physics syllabus. So, it's one topic that you must surely see question on. And our point of focus here is going to be what Hooke's law and force constants. So, we're going to talk about everything about the Hooke's law, force constants. Now, we want you to understand. Then we want to look at what various calculations, various formulas you need to know you can use to solve any calculation at all you see in the exam, right? So you want to stick to the ends of this video so that you can take down every single thing. Make sure you have your notes, your pen, and your calculator to follow through at this video. Do you understand? So let's look at what the introduction first. So we are talking about what elastic property of solid. So now take out all these things here. So solid materials are elastic, meaning that their shapes and size change when they are compressed or extended by a force, but regain their original size and shape once the force is being removed. So, because I talk about elastic properties of solid here. Now, there's a solid that when you deform them or you expand them, now, like when you apply force on them, what up here? They will expand or deform, right? But immediately you remove that force, it will go back to they will go back to the original size or shape. So those solid materials that regain their size and shape when a force is being removed is called elastic. So those solid possess what we call elasticity, just like the rubber band. Like the rubber, like we have called the rubber band, the rubber, the spring, and the steel. These are solid. These are solid. They are what we call that possess elastic properties. So when we talk about elastic properties here, these are properties that some solid possess when the force that be applied to it, when the force be removed, they can what? They go back to the original size and shape, in the sense that you can expand them and you can deform them. Do you understand? So when you apply force to expand them, they will change their size and shape, right? But immediately what you remove the force you apply, they will gain their size and shape. That is called elasticity. It's called what? Elasticity. Do you understand? It's called what? Elasticity. So that is what the concept of what elastic property of solid. Do you understand? So we have to look at what. So the main law that guide what elasticity is called the Hooke's law. It's called what? The Hooke's law. So now, what is Hooke's law? What is Hooke's law? Okay, so let's look at what Hooke's law here. Hooke's law states that the change in the length or extension E of an elastic body is directly proportional to the applied force or load F, provided that the elastic limit of the body is not exceeded. So what elastic limit, what Hooke's law is talking about is this: the change in length either or the extension, because we are called change in length. Either because if you have a rubber band here and you apply force, now you are what change in length, right? It has expanded, the length has increased, right? The change in length or extension. So the change in length is just called what? Extension. That is, you extend it. Do you understand? The change in length or extension of elastic material is directly proportional to the applied force. That is the force you apply. That is directly proportional to the applied force, provided that the elastic limit of that material is not exceeded. So look at something here. Every elastic material have what we call elastic limits. Now, once you apply a certain force and you get to a point where the elastic when the material cannot regain its original size or shape, we have seen that it has exceeded the elastic limit. Do you understand? So when you are stating Hooke's law here, it must be under the elastic limit, provided that the elastic limit of that material is not exceeded. So in the sense that in Hooke's law here, the force you apply is directly proportional to what? To the extension, which is the E. The extension also now what change in length. Just as so you can have length 1, you can have what length 2. Do you understand? So this is called Hooke's law. The force applied is directly proportional to what? To the extension or change what in length. Do you see that? So now, for you to remove the sign of proportionality here, we need to introduce a constant, right? We need to introduce what a constant. But first of all, let me explain for you. You know that the higher the force, the higher the length. The lesser the force, the lesser what the length. That is mean when you say direct proportional. So when the force increases, the length or the extension increases. Hope you understand. So for you to remove the sign of proportionality here, what we want to do here is to introduce a constant. Going to be F equals to what? Ke. Is okay. So this is the force applied. This is what is the what? The extension of the what? Elastic body or elastic material. This one is called elastic constant or stiffness constant. So K is called force constant. So this K here you are seeing is called force constant or stiffness constant, right? Remember, force is equal to what? Mass times acceleration due to gravity, right? So therefore we can say mg equals to what? K what E. So you can take note of this one here and this guy here, right? Now, but we want to do something here. We want to derive other equation that will make solving of Hooke's law or question concerning Hooke's law more easier for us. Do you understand? So we have to derive some specific formulas so I can understand the stuff very well. So it's going to be shortcuts or alternative what formulas or alternative what method. Remember, if for example here we use this one here, so we are still going to bring some here. F equals to what? Ke, right? Now if you should what make K the subject of formula here, if you want make K the subject of formula here, what are you going to get? It's going to be K equals to what? F over what? Over E, right? Now remember this one is called stiffness constant or force constant. So now this is how it look like here. Let's imagine that we have elastic body here, right? We have elastic body, right? If you should apply a force to it, if you apply a force, what will happen here? You are going to get your first extension, right? You're going to get what? Your first extension. Like you're going to get something, you're going to get your extension. Now, if you should apply another force here, like if you should also expand it, what will happen here? You're going to get second extension. So here we can have F1 and what? E1. Because I what? F2 and what? And E2. I can also have F3 and what? And E what? 3 is okay. Now, in Hooke's law, right? Provided that the elastic limit is not exceeded, everything will also go back, right? Provided that the elastic limit is not exceeded, this K will be the same when we have force 1 E1, when we have force 2 E2, when we have force 3 E3 here. Do you understand? So this will be constant as far or as long the what? The elastic limits of the material is not exceeded. As far as the material regain its size and shape. Now, F1 and E2, this K will be the same, this K will be the same, and what this K will be the same. Just as so they're not like K1, K2, and K3. The stiffness constant of that material will be the same as long as the elastic limit of that body is not exceeded. So with this knowledge here, do what I'm going to do here. Here you can just say, remember I told you that if you will make K the same formula here, we have K equals to what? F over what? Over E, right? So force 1, we have what? E1. Force 2, we have what? E2. Force 3, we have what? E3, right? So do you want to go to apple? So going to be K is equals to what? F1 over what? E1 equals to what? F2 over what? E2 equals to what? F3 over what? E what? 3. Is it? Do you understand here? The stiffness constant will be the same for all the force applied as long as what? The elastic limits do not exceed as long as the elastic body or elastic object do not exceed the elastic limit, right? So the stiffness constant will be the same. So what we want to do here, remember, F is equals to what? G, right? That is the mass of the object, and the G. So what happen here? If I have force one, so my F1 will be what? M1G. Is okay. My F2 will be what? M2G, right? And my F3 will be what? M3G. So what happen here? We want to focus on what F1 and what F2. Do you see that? So we are going to ignore this one here. So we are going to ignore the third one. Our focus is just going to be what? The two of them. Hope you understand. So our focus will be what? F1 and what? F2. So what does it mean here? We can rewrite this thing to be what? Like, so here we can say F1 E1 equals to what? F2 E2. What happened here is that here we can say M1G over what? F over what? E1 is okay. Equals to what? M2G over what? E2 is okay. We can have this one here. Now, we can also have this thing to be what? Like, we can take this one here and take this one here. You can say M1G over what? E1 equals to what? F2 over what? E2. Or we can say what? F1 over what? E1 equals to what? M2G over what? E2. So you have to take note of these two things here. These are the formulas we are going to make use of. So here we have these two here, and we also have this one here. So these are the formulas we are making use of when it comes to what? Hooke's law. Right there. So when it comes to Hooke's law here, these are the various formulas you are making use of. As easy as that. So now let's start solving some key problems in order for you to be able to know how to use these formulas to tackle questions when you see them in the exam or any exam at all or anywhere at all. Do you understand? So now let's start solving some questions. Okay, so let's solve these two questions so that you understand how to apply this formula to solve problem under what? Hooke's law. Right? So let's look at what the first question here. They say that a spring of length 5 meters is extended by 0.04 meter, right? By 0.04 meter when a load of 0.8 meter, 0.8 kg is suspended at the end. How far will it extend if a force of 16 Newton is applied? If a force of 16 Newton is applied. So we'll go back again and read the question, because before you start solving any question, first you must understand what the question here. This is that a spring of length. So the length of the spring, the length of the spring is 5 meters. So the length here can say L is 5 meter, right? Is extended by 0.04. Now this is the extension, is extended. So the extension, is going to be E1. So my E1 is what? Is 0.04 meter. This is the extension when the load will apply. This is that when a load of mass, when a load of 0.8 kg, so that is my M1, which is going to be what? 0.8 kg. Can you see that? That is what my M1 is suspended at the end. Hope you understand. So a spring of length, the length of the spring is what? This. The extension, which is the E1, is what? 0.04 meter. The mass is what? 0.8 kg. Just that. Say how far will it extend if a force? That's about what is second extension? Just that. So it's going to be E2. So my E2, that's what they say you should look for. E2, that's what they say you should look for. And the second force applied, which was F1, F2 is what? Is 16 Newton. So how do we solve for E2? Remember, I told that F1 all over E1 equals to what? F2 over what? E2, right? Now, if you check very well, I don't know my F1. Do you understand? I don't know my F1, but I know that my F1 should be on M1G. Is okay. So now I know what my E2. So I know what my F2. What I've calculated is E2, right? I know what my first extension. So what I want to do here is in the place of F1, I'll put M1G. So therefore, you're going to do what? M1G over what? E1 equals to what? F2 over what? E2. Can you see that? So what I want to do here is what makes this guy solve a formula here. It's okay because this is what you're looking for. Cross multiply, right? If you cross multiply here, you're going to do what? M1G times E2 equals to what? F2 times E1, right? Divide both side by what? M1G. So M1G, right? This will cancel out this guy here, right? So what I have left is what? Therefore, I will have what? E2 equals to F2 times E1 over what? M1G. So what I want to do here is what? Impute your values given. Impute your values given here. My F2 is what? 16 Newton times my E1. What is my E1? 0.04 meter, right? Over my M1 is what? What is my M1? My M1 is what? 0.8 kg times my G is what? 10 meter per second what square. Do you see that? So what happened here is this. So you can ignore the unit here. So here we can say 16 times 0.04, right? Divided by here we have 0.8 times 10. Here we have 0.08 what meter. The extension is what is meter here. Do you understand? .08 what meter. So as easy as that. So what about if I should change value here? Now let me change the value so that you solve and drop your answer at the comment section. Right there is applied. So I have changed the value here, right? I have changed the value. Go ahead. Here we have 0.065 meter. Here we have what meter. That is the extension. It's okay. So go ahead and solve this question for me, right? So pause the video, go ahead, leave your answer in the comment section. Look at something here. Now, let me tell you one thing here. One of the secrets that will make you to become very good as a student is your ability to solve questions, right? So, because some students will say that I'm going to solve it later. Don't learn to start procrastinating at this your stage as a student. If there's anything that should be done, it should be done at once. Now, I've said you should pause the video and this here. Can bet 90% of students will not do that. Only 10%, and 10% will not be serious. So if you are more than 90%, I just feel sorry for you because you think that you solve it later. At the end, you never go back and solve this thing. So I said, pause this video now before you continue because some people don't hear well. Some of you students don't listen at all. Don't listen to instruction. Pause the video now. Solve this thing. Drop your answer at the comment section. It's very important. Let's start at the comment section. Now, but before I continue here, now, if you really want to learn very well, like you really want to learn very well, then sign for my private online class, right? Sign for my private online class where I will take my time to teach you. Instead of you waiting for me to upload video, we have our timetable where we learn every single day. Now, we have two classes. We have called private one-on-one. This is where I'm going to have personal one-on-one with you. We also have our private group chat. Just private group chat is our 8,000 naira monthly. But currently now we are on discount 5,000 every single month. So now before it was 4,000, but I've got the numbers of students for that 4,000. Now it's now 5,000. So if you're listening to me and you really want to, you're eager to join my private online class for JAMB, then send me a DM where you can sign chance to pay 5,000 naira every single month. Once I get the numbers of persons I'm looking for in this 5,000 naira every single month, I'll increase to 6,000 before I get to my 8,000. So if you're watching this video here, the price is now 5,000 naira every single month instead of 8,000 naira every single month. So if you want to join the class, send me a DM on my WhatsApp that you want to join, you want to pay for the class, and I'll send my account number. I make payment. Just you really need a well structured class that will be of help to you in your JAMB preparation, not just watching random videos. Because sometimes we think that by watching random videos they will understand very well. No, you need a well structured class that will help you guide you. This is what you are supposed to read. This is what you are supposed to read. This is what you are supposed to read. These are the assignments. Make sure you do it and submit to me. Do you understand? You need someone to hold you accountable. When you don't do your assignment or when you are busy, when you forget, that somebody is there to hold you accountable. Do you understand? So if you want to join the private group chat, send me a DM. For those of you who don't want the private group chat, you want the private one-on-one class. That one is what is costlier than the what private group chat. Do you understand? You can send me a DM and I will attend to you. So let's look at what question 2. Let's solve question 2. They say that a spring of length 4 meter extended by 0.02 meter when a load of 0.4 kg is suspended at the end. What would be the length? What would be the length? What would be the length of the spring when the applied force is what 15 Newton? This is exactly what you have done. But here they're asking you what is the length that what would be the length of the spring when the force is applied. Just so now therefore my L the length of the spring is what is 5 meter. Sorry, is what is 4 meter. 4 meter. That is the length of the spring, right? Now my extension, that is what my E1, right? This is going to be my E1, my M1, right? So my E1 is what? My E1 is 0.02 meter, right? My M1 is what? My M1 is 0.4 kg, right? Now, for me to be able to calculate the length extended, like what is the length when the force was applied, I need to calculate what the second extension when the force was applied. You understand? So it's going to be E2. We don't know the E2 here. It's okay. So, but my force F2 is what is 15 what Newton. It's okay. So M1G over what E1 equals what F2 over what E2, right? So this formula you are using here. So if you make this E2 the solve formula here, you have E2 equals what F2 times E1 over what M1G, right? So when we make sure you solve formula here, so what we want to do here, so what input what our value here, E2 equals to what F2 is what 15 times E1 is what is 0.02 over M1 is what is 0.4 times G is what 10 meter per second. Right here. So let's write our calculator. Let's get our answer. So it's going to be 15 times 0.02 divided by 0.4 times 10. So here we have 0.075 watts meter. I get. But what is the new what? What is the new force? What is the new length? Because I said what will be the length of the spring when the force applies this. So that is my new length is going to be L2 because of what L plus E what 2 is okay. So that is extension when the force was applied. This is extension. So to get the new length now, you got to be the original length over plus the extension you have already calculated. So going to be what? Therefore, L2 equals to what? 4 meter plus what? 0.075 watts meter. It's okay. You're going to be what? 4.0075. No. So when you add them together, you're going to be what? 4.075 watts meter. This is what is the extension. Just so in our private class, we're going to solve more difficult problem, like problem you like to see in your exam. So these are the ones we are going to solve in this free class. But if you want to join, if you want to learn more, then learn the second part, which is called tensile strength and young modulus. we have to do that one in our private group chat, either in what in the one-on-one or in the general in your private group chat. Do you understand? So if you want to join the class, send me a DM and you'll be added to the group chat. Don't just wait till when exam is 1 month before you start preparing. At the time of me creating this video here, we are about to enter January, right? So you can see you still have enough time for your what preparation. If this video is helpful, please like, comment, share that this video is helpful. Thanks. See you in my next video.